So we're going to review for your second test, and this will cover the Ammitrol sections here under reversing motor control, automatic input devices, and basic timer control on and off delay. So those are going to be the skills that you're going to be tested over. So I'm going to go over the test, and we'll answer any questions you have in class. So the test is going to be, it's going to be a small test. There are 24 questions. 23 of them are multiple choice, true and false. The last question, if you'll remember, I had you quizzed over doing a forward reverse from memory. So we're going to do the same thing on the final test, except if you'll remember last time I said you don't have to do the high voltage was for bonus. Well, this time it's not for bonus. You're going to have to draw the high voltage wiring side of the diagram. You'll get the same diagram you did in class. The low voltage side, it shouldn't be an issue. If you miss the low voltage side, there's not much I can do for you, but if you'll look through the test, you shouldn't have any problem doing the low voltage side of this drawing. So really we're just testing on the high voltage side. We'll go through the questions. They're coming be very similar to your Ammitrol questions, so I'll clear all these off, all your grades off. If you want to take the quizzes again, that's probably your best review you can do. You need to know that a reversing magnetic motor starter uses magnetism to pull in and out the coils to change the direction of the motor. You need to know how to reverse the direction of a three-phase motor, swap any two leads. You need to understand what interlocking is, and that when we interlock a forward-reverse contactor, we are doing that to prevent the forward or the reverse becoming energized at the same time. You need to know what a sump pump circuit is. That's if you have like a sump pump in your house, you don't want to run the pump dry, so you have either a float or some type of level switch to tell you whenever there's water in the pit to pump it out. You also need to know that on a standard float switch that we looked at, the up and down movement of the little switch controls whether it comes on or off. You need to understand sequencing on a circuit. So for example, if I had a circuit I wanted to turn on the one motor after another motor started, then I would tie that in with the power going to the coil of M1 would feed power to the circuit of M2. So we need to understand that those diagrams have to be in there. I can give you an example here. Here's your example. So you can see that in order for M2 to run, that M1 must be on. So you need to understand that circuit there that we would interlock. Remember I told you also that if you keep stacking these on, that all of the current for all the contactors will be coming across this one stop input, which can lead to some problems. If you overload that stop input, you can pull too much current on it. You also need to know that the same problem we have with manual switches, we can have with automatic switches. The contacts can weld closed. They can have mechanical failure, different things like that. You need to understand how an off delay timer works. Remember, in the case of an off delay timer, on our example, we had the digital timer. Whenever we applied power to the start input of the timer, the contacts of the timer immediately changed. Whenever we killed power to the start input, then it began timing off. You also need to know that one of the methods for unloading a big air compressor during startup, so you can start the motor unloaded, is to use a timer. So when you start the motor, it starts a timer. This will be the exact example of what we did in class, that whenever it reaches its preset, it comes on. If we want to look at that, we can. And that would be an example here of our forward start. And once we begin to run it, we start the timer, we start the start input. Then after a preset amount of time, this on delay timer closes. Then this could be load the compressor at speed is what we put on that other one, but it could be anything of that nature. So typically you also need to know the difference between the selector switches. Like a handoff automatic control uses 3-position switch. If you have either just a manual or auto control, that would use 2-position switch. You also need to know that the most common way for people or operator is when we change from manual autos, we use a selector switch. You also need to identify the types of interlocking seen in a forward reverse circuit. So you remember our circuit that we did. In this example here, we had electrical interlocks or mechanical interlocks here and electrical interlocks here. So you need to understand what those are. You need to understand the different parts of a reversing magnetic motor starter. So if you're going to have a standard reversing magnetic motor starter, first of all, there's a few things you have to have. You have to have overload protection, and then you're going to have the forward contactor and the reverse contactor along with everything else that comes with it. You also need to understand a drum switch and how it works and how this diagram reverses. So if I were to reverse this motor, then I would show these connections here. I would show that L1 here is connected to terminal 3 here. So notice this diagram here shows that they are connected there. And I would also need to know that L2, 4 is connected here to 2 over here. So 4 and 2 get connected here. So you have to look at these diagrams here and we'll see that 5 and 6 in the reverse would be L3. So we'd see 5 and 6 would be connected here. So you need to be, because you'll get this diagram and you'll get asked, if I'm in the reverse connection, what will I be? And so you'll have to spell it out for them. Know the types of automatic input devices. You've got pressure switches, float switches, limit switches, and stuff like that. Manual input devices, they include like push buttons and selector switches. So any type of contact that is actuated by a device, something that a operator or technician doesn't actually put their fingers on, is going to be an automatic switch. Know the difference between set point pressure and reset pressure. That's called the differential, sometimes called the deadband. That's the range where we don't care that our pressure is in range. So if we had an air compressor and it had a pressure switch, remember you have two settings on that. You have the point where it kicks on and the point where it kicks off. So typically if you have your air compressor at your house, it's probably set to kick on when it gets below 100 and go off when it gets to 110 or 120. And so between 101 and 119, that would be its differential setting or dead band, or it doesn't really care. You need to know your limit switch symbols. I know you've had them before. In this case right here, we have notice that if it is in its static position with nothing activating it, that we have four possible states. We have a normally open, held open, right here. So this is normally open and held open because there's something pushing it open. No, I'm sorry. This is normally closed, held closed. This is a normally closed limit switch. This is a normally open limit switch because the contacts are below, but it is normally open, held closed. And this limit switch here is just a normally open limit switch because gravity's pulling it down. So if gravity was pulling it down and it got pushed up in its static state, it would still be a normally open limit switch, but it would be normally open, held closed. And then this would be just a normally closed switch. This is also a normally closed switch, but the contacts are above here, so when something was pushing up on it, it's normally closed, held open. Know the different types of circuits. You would have sequencing motor control in there. Typically a conveyor system where you need the conveyor to run in front of it. Maybe you need a cooling fan to kick on after a machine is running, or some type of lubricating circuit. So any of those would be a sequencing control. It also talks about what type of timing mechanisms a timer relay uses and which ones are probably not going to be used. You're going to pretty much always see a solid state timer, but in the past they've had pneumatic timers. Okay, they used a little pneumatic bellow, and then you've had motor-driven timer circuits, which had a tiny little motor in there that had a little gear ratio and it knew how far it turned, would activate something. But the pneumatic and the motor-driven timers are pretty old school. All you're really going to see now are solid-state timers. You will not, however, see anything that works on a hydraulic or water type. You need to identify the contacts of a on delay, off delay. So you need to know if it's a normally closed on delay or normally closed off delay. Refer to your schematic diagrams that I gave you if you need to review those on the type of contacts between a normally open and normally closed time delay contact. You also need to know that what is called a time-driven sequence, that's where you use timers to control the sequence of a machine regardless of feedback. You also need to know the potential failure problems of a timer relay. They can get stuck closed. You can have a mechanical problem with the timer. A little plastic could break in there on the little contact block. Or you can have the contact is shorted. So those are some of the things that can happen. Pretty much the same thing that's going to happen with a relay. Ice cube relay is going to happen with a timer relay.